Hey, hello everyone, and welcome to another NYJavaSIG event. Today, we're gonna have Almas talking about FXGL. But before that, a few announcements. First, if you're not following us, please do it here on Twitter. We have over 1,700 followers. Please, you want more, let your friends know about it. Or YouTube will have about 1,100 subscribers. Please join, subscribe if you're not subscribed yet. Following us on social media is how you can get notified about our next events. We have monthly events, sometimes twice a month. Great content, great speakers, and it would be nice if you let your friends know about it as well. I would also like to thank our sponsors. So we have here Agile Learner. It's a great source. It's from Venkat Subramania, one of the great names around Java. There's amazing content about Java, Kotlin, design patterns, Agile, microservice. He's a great speaker. And follow us. We do very frequently, we do raffles of subscriptions. And another one of our sponsors, JetBrains. So JetBrains, thank you very much for sponsor. And taking the chance, JetBrains is kind enough to give us a few licenses that we can raffle with you. And today we're gonna try to do something different. So here on Twitter, this is our Twitter handle, okay? Send a message, tag NYJavaSIG, okay? And let us know which topic or speaker would you like to see here next, okay? Use the hashtag NYJavaSIG topic. I'm gonna put here on the chat as well. Everyone that participates will join a raffle that will, you can get one license, yearly license for any JetBrains IDE. Okay. Now, in partnership with Foojay, we're doing this event today. Foojay is a place for the friends of OpenJDK. And I would like to introduce Herten to say a few words about OpenJDK. Herten, please, it's with you.
Thank you so much, and thank you all for being here. My name is Geert-Jan. I'm in Amsterdam in the Netherlands, and we are right now promoting a new Java collaboration platform called Foojay. So there is a tour that's been going on since last month. We visited about 10 different junks last month, and so we're getting to the end of the tour here in New York, and in a bit also in Hamburg. So the last few stops of the tour. And what we're doing is getting the word out about Foojay. And Foojay stands for Friends of OpenJDK. So if you look carefully, the word Foojay, you'll find that inside of Friends of OpenJDK. And you can see here there's a J in there, which is a bird. So we have a nice logo. And we have a foo here, which if you've ever done any Java demo apps, you know that you use foo and bar as variables. And you should really see Foojay as a placeholder for your content, any content relating to Java. So if you're getting started with Java, so complete beginner tutorials, but also really unique content that you won't find anywhere else. For example, what's been going on in the Java world over the past years, of course, is that there are now a lot of different releases, a lot of different updates. There are quarterly updates, and there are major releases which are coming much more frequently than they did years ago in Sun Microsystems. But does anyone actually know what is in those updates? In fact, it's April 2021. And just this week, another release came out, an update to Java 8, to Java 11, to Java 16, and so on, with many improvements. But where would you go to find out what is actually in those improvements? So if you're using Java 11, for example, there is now, since Tuesday, so this is completely new, there's 11.0.11. And here is a list of the 227 issues that are fixed in that release. So for a start, where would you go to find that list? But also maybe it makes more sense to break them up into different components. So you might be interested in security, for example. So here you have a list of all the security fixes in this particular update. Now, even this is kind of a hard read. So as you browse through this, you might pick out a few that you find interesting. So you will click on the star to say that you like those. And the most liked fixes are automatically found within the highlights page. So here you get a community view onto what the community likes most about the newest fixes, in this case, for the update to Java 11. Now, if you look back in April last year, you will see that over the past releases, on the highlights page, you also get an additional commentary. So, for example, the title of an issue could be something like this: simplify jar file is initializing. Now, the commentary that Foojay adds here is, for small applications, this noticeably solves a regression in startup and footprint. So this could be a reason to upgrade to Java 11.07 or higher. So what we want to do with Foojay is to bring to the surface a lot of information that is kind of hidden, and also to annotate and analyze it. Another example is, since when I was working for Sun Microsystems many years ago, there is now not just, of course, one Java vendor. There are multiple Java vendors. There are multiple different OpenJDK distributions. But do you know what they are, and do you know where to go to find those distributions? There's Oracle's OpenJDK, there's Amazon's OpenJDK, there's Azure's OpenJDK, there's Bellsoft, Red Hat. So here on Foojay, you get the whole list of the different OpenJDK distributions. And this is actually provided by Mark Hoffman, a Java champion, who has a site called javaalmanac.io. And similarly, where do you go to find the JVM command line switches? Now, there are thousands of these. Here we are in Java 11. You can see here, there's 1,989 JVM command line switches, and also 53 are new and 27 have been removed in Java 11. And this information is there for each Java release, plus what all these different switches are. And you can also imagine that we, at some point, would add some kind of voting mechanism here, so people could vote on their favorite JVM command line switches, or annotate or provide additional information on a particular JVM command line switch. And in the same way as with this list that comes from a Java champion, this one does too. So here we've integrated with Chris Newland his content from a site called Chris Who Codes. So you can see here there's a pattern. What we want to do is not necessarily create new content, but bring together, integrate information related to Java that has been spread all over the internet and elsewhere. Because while it is wonderful that there are so many different OpenJDK vendors and so many quarterly updates, it's really difficult to keep track, and it can lead to a sense of fragmentation and not knowing where to go to find Java information. And so this is what we want to do with Foojay. Now, in addition to all these different kinds of data-oriented, information-oriented content, we also focus on providing Foojay Today, which is a blogging area. And 5 days a week, we have a new article published on Foojay. And the authors, there's a lot of authors. Foojay has existed for about a year at this point, started in April last year. And here are the authors so far. It could be you. Anyone is welcome to join in. So a lot of people here you probably will know about in the Java community, like Marcus Hurt, the creator of JFAR, Matt Rabel, Raid Sang, many very well-known Java people. Almas, who will be speaking in a bit, has content here too. So there's really a diverse range of people. What Foojay is a WordPress site. So if you want to contribute your blog content, either new or republished, you will get a user and a password. You'll go in, you'll queue up your content, you'll put them in draft. The nice thing about WordPress is everyone basically knows how to use it. The horrible thing is, of course, it's not nice. It's not a very nice way of doing things. Ideally, we would have a Java-based platform, and it would be on GitHub, and that's ultimately what we want to do. But for the moment, WordPress is fine. So you would queue up your content, and then every Monday morning, we on the Slack channel, so Foojay has its own Slack channel, of course, we plan the week. So here's, so we make a proposal, Monday this article, Tuesday this article, and so on, and we discuss what we will put on the site. So it's really community driven, and that brings us to the next point. Who are the organizations behind Foojay? Now, firstly, it's an initiative of Azul. Now, I work at Azul. I'm a director at Azul, focused on open source projects. I used to work at Sun, primarily on NetBeans, and I used to work in Oracle, primarily on bringing NetBeans to Apache. And now I'm in Azul, and I really started working in Azul primarily to work on this project, because there's clearly a vacuum in the Java community in this area. So Simon Maple from Sneak puts it really well. He says, it's incredibly important for every ecosystem to have a core location for information to help grow the community and to be an educational resource for all developers to use. Java has lacked this core space for many years. And so what we're trying to do is fill that space. And these are the board organizations. So these are all pretty well-known Java technology organizations. Azul, Datadog, DataStax, Hazelcast, JFrog, PR, and Sneak. From JFrog, Steve Chin, I'm sure most Java developers have heard of him. Marcus Hurt from Datadog. So there's a lot of key community leaders involved in this project. So that kind of wraps up what I wanted to share. Ultimately, what we're going to, with all this content, and this is why we're doing this promotional tour now and not a year ago, is we want Foojay to be the Wikipedia for Java developers. That's the vision. So imagine that you're interested in JavaFX. So you type JavaFX on the search, and the search goes across all the different artifacts in here. So you can see the fixes that have been done in the JavaFX area, also the blog posts in the JavaFX area, the tutorials, security CVEs, across all the different artifacts, you can do your search. JFire, for example, Java Flight Recorder. So you can see a lot of work has been done in Java Flight Recorder compared to JavaFX. That's an interesting statistic. Look at this. If you look at the issues, 447 issues have been fixed over the past year or two in the JFire area versus JavaFX. Let's take a look here, 26. I mean, that kind of information, it's really hard to find, but really easy if you have a search engine and you have a lot of content like this. So the important thing is Foojay becomes more meaningful the more content we add. And of course, the more meaningful and more useful content. We also want to have a forum, of course, at some point, and that we will do again through integration. So we'll take the Java section of Stack Overflow, which has an API, and plug that into Foojay. So, and also, if you are in education, think about this. There's all these categories in this on Foojay today. We could have a section here on education, or we could have a student section here. I mean, one nice thing that we could do as a community is bring students into the Java community. Typically what happens, you learn about how cool Java is and the community and the conferences and the whole ecosystem once you've actually left university or college or whatever. Wouldn't it be nice if you were already blogging and sharing information with Java champions by means of Foojay while you were studying? Another example is the release notes. So where else online, while reading about Payara's release, so I'm reading here about Payara's release, will you also find information about WebLogic's release? So we can cross-post our release notes on our various Java technology sites and put them on Foojay as well to have a shared repository of all the release notes across the Java community. So there's many different opportunities that we have here. Another area is community managers. So you'll see that they're not just authors, but there's also the idea of community manager. So the IntelliJ IDEA area of Foojay is run by somebody from JetBrains. So a developer advocate, great developer advocate, Helen Scott from JetBrains runs the IntelliJ area on Foojay. Similarly, the security area is run by Brian Vermeer from Sneak. Sneak is a great Java security company. Similarly, who does DevOps really well in the Java world? Well, JFrog. And so developers from JFrog are the ones that kind of run this and gather content around DevOps. So there are so many interesting ways that we can, as a community, work together around Foojay, because it's really low threshold and easy to get involved. So that is by means of the Slack channel, as I mentioned. So I'll put a link into the chat about that. And also, of course, Twitter. So if you follow Foojay on Twitter, so it's Foojay.io on Twitter, you will every day of the week, of the work week at least, get a tweet with a new tip or a new article or a new insight related to Java. It's really narrowly focused on Java. So please follow Foojay on Twitter. And we recently crossed the 1,000 followers mark in a year, which is really pretty good. So the more people join in here and share tips and tricks and insights and so on, the better. In short, if you are using Java and the OpenJDK, you are by definition a friend of it. And you could join in with this community and share your insight and knowledge and learn together and collaborate around Foojay. Thank you very much. And now I will switch back. And the speaker that you'll hear from is Almas, who's really involved as well in the Foojay community, talking about FXGL, which is a fantastic game library on top of JavaFX. I mean, the cool things I've seen with that, I hadn't expected to ever see in Java. So I'm really excited to have him speak here in this part of the tour. I think we're switching to Rodrigo. Or to Frank, yes. Introduction to FXGL. So here we see some of the animations and effects that you get by means of FXGL on top of JavaFX that Almas will talk about.
Yeah, it's just more of a sort of an introduction trailer to give an idea of what is possible with FXGL. Okay, let me take over the screen sharing now. And then we'll begin. Can you see my screen all right?
Perfectly, yes.
Yep.
Cool. Right, in which case I'll begin. Today, we'll be talking about the FXGL engine introduction. It's a game engine for essentially JVM. You can use it with Java, Kotlin, or any other JVM language. And before we do that, I'll just very briefly introduce myself. My name is Almas. I'm a senior lecturer in game development at the University of Brighton in the UK. My PhD is in computer science, particularly in visualizing Euler diagrams and graphs. I'm the author and maintainer of the FXGL engine, which is what we're looking at today. And I've got the YouTube channel focusing on JavaFX, Java, Kotlin, and a bunch of other technologies. So the outline of this talk is we're going to look at some of the commonly used engine features, and then there will be a short practical example towards the end. So what is FXGL? It's a high-level framework that aims to make JavaFX game development considerably easier. Initially, this was the statement, the philosophy behind FXGL. But as it grows, as it matures, it's slowly getting into JVM development as well, so that it's no longer just JavaFX game development, but it could be Java and or Kotlin game development. And if we were to take all of the features or all the things that describe FXGL and put it on one slide, then this would be the sales pitch for it. For starters, you don't need to install it, or there is no setup required. You just use it as an external Maven or Gradle dependency, and it's ready to go. It supports Java 8 all the way to Java 16, and it supports Windows, Mac, Linux, because JavaFX does. And using, with help of Gluon tools, we're also able to compile FXGL games to Android and iOS. And also embedded, so things like Raspberry Pi. And also with help of JPro, we can compile our games to web. But these are still in experimental mode. FXGL is a direct superset of JavaFX, which means that you don't really need to learn any new API when it comes to user interface. And because it's seamlessly built on top of JavaFX, that means anything that expects a JavaFX application, any kind of technology such as Gluon tools, JPro, JavaFX Maven plugin, and anything else will just seamlessly work with FXGL applications. In other words, if you can build something with JavaFX, then you can build that same thing also with FXGL, potentially much easier, in a much easier way. FXGL also supports both 2D and 3D. It initially was just a 2D game engine, but then after the JFX conference, JFX Days conference, we had a lot of positive feedback and sort of guidance towards developing the 3D support for FXGL as well, which is why we now do support 3D. And slowly getting from alpha to an actual non-experimental mode. You can build games as well as business applications in Java and Kotlin. So it doesn't really matter what language you use, as long as it's JVM supported. So I guess Scala is also going to be on. The license is MIT, and that means you can pretty much do anything you want with the code and the things that FXGL produces. So you can use it for hobby or academic purposes, and you can also use it for commercial projects. The games or applications are packaged either into a single executable jar or something that's getting more popular right now is native images. So you're able to produce a platform-specific image and supply that to your clients. This is the community around FXGL. This is primarily the academic community that I've included. And this includes institutions that use FXGL for teaching something, either computer science, software development, game development. And I certainly use FXGL at the University of Brighton to teach a bunch of game-related modules. This is just a quick diagram to give an idea of how big the architecture of FXGL is. It's been in development for about 6 years now. So there's a lot of stuff in there. There are a lot of features that FXGL supports just out the box. And these include logic related to game objects, game world, game state, AI, physics, gameplay, user interface, graphics, networking. So there are a lot of sort of areas of game development as well as application development that FXGL supports. And we're just going to get a taste of some of these features in this talk. We're going to focus on some of the commonly used ones. FXGL is fully open source, so these are the links to where the source is located on GitHub. You can also find a bunch of FXGL games using this second repository. There is the community chat and also GitHub discussions that have been enabled, and the trailer that we saw earlier at the start of this talk. So at this point, hopefully you're thinking about what the minimal example is, or how can we produce a minimal example with FXGL. This is something that I quite like because it fits on one page or on one slide. The settings are reasonably straightforward. You set the width of your game, the height, the title, and even if you ignore these settings, defaults are provided. You can actually remove these 3 calls related to width, height, and title. Then the only thing you're left with is public static void main. And I assume Java developers were just familiar with what public static void main is. And if you start this, it will give you a sample window of given width and height, given title, and there will be nothing in your game since we haven't really added much. But it is going to be a functioning application. So from now on, I'll be going through the features, focusing on what they do and providing a screenshot where applicable. So experimental 3D mode, soon it's going to be non-experimental because the questions around design, software design have been figured out. So 3D is here to stay, essentially. And this is an example from height map procedural generation for to produce this world, which we just then render using 3D. Essentially a 2D world that we transfer or convert into a 3D space using Perlin noise. Using a similar algorithm, but this time it's backtracking rather than height map generation, we can make a maze and then use the walls to, we can turn the walls into 3D objects. And what we get back is a 3D maze in which we can move around. And this should potentially give us a playable level for a game that I haven't really thought about yet. The latest version of FXGL is 11.15, and that introduced custom shapes. So these 3D shapes that you can see are now built in and can be used for any purposes. And these were designed in a way so that they're uniform, as in they have the size that kind of matches what JavaFX provides by default. So the cube on the left is the default shape that's provided by JavaFX. And so is the sphere, which is the second from left. Everything else is generated by FXGL. Some of these things use formulae that come directly from FXYZ, which is a different project for 3D JavaFX. And using these custom shapes, we're able to soon combine them into more complex shapes. And we can even manipulate each of the vertices of these shapes. So API is in draft currently, which allows us to manipulate each vertex of the 3D meshes that you saw earlier. And that allows us to produce quite complex animations, actually. And you can also generate something like this using the same API at runtime. This is essentially taking one of the built-in shapes like a cylinder and then translating each of the vertices using a specific function to give us an isomorphic shape, essentially. It's isomorphic because we don't really change the structure. We're just moving vertices around. The internal structure of vertices and edges remains the same. But you can see that it's quite interesting how a cylinder can become this shape, which looks like a flower. There's also a demo that allows us to integrate FXGL and FXYZ into this Christmas example. or sample scene, if you will, which is essentially the trajectory for 3D support. This is where we want to go ultimately, to be able to do that just out the box. This is an experimental run on Raspberry Pi. Frank Delporte and I have tried to get a snake game running on Pi, and we succeeded. So this is a screenshot from Raspberry Pi. And there is also a link in the on the slide that you can then follow. All these links will be then published at some point, and I'll provide links as necessary. So follow up and then see how to implement various things with FXGL. And this particular example shows how to build stuff for Raspberry Pi, which could be quite an interesting avenue to explore. Complex controls are easily doable because FXGL is based on JavaFX, which means all the graphics stuff, all the user interface controls, all the shapes that you get from JavaFX are easily accessible, usable. You can combine them in whatever form you like, and you can produce quite complex user interface, I suppose, objects. With asset management, which refers to things like loading external resources, this is how you load an external resource into FXGL. And this is all unified under one service called Asset Loader Service. You essentially say something like load sound, and it will look for that sound effect under assets sounds directory. If it's loading music like MP3 files, it will look for these files under assets music, and then so on for other types of assets like textures, levels, fonts, CSS, JSON files. FXGL ships with customizable style menus, so you can just run your game, and if you enable the menus, then you'll be greeted with something like this. And you can customize pretty much every bit of that menu. You can provide your own scene factory. So this is how you would do it through code. And you would override the main menu method to provide your own menu. And using this approach, you're able to achieve something like this, which looks completely different to what we just saw, but has more or less the same functionality. So the actual functionality is driven by the same API, same code. You're just changing the view of your menus. And this is another example from Space Wars, which, again, it's the same API underneath, but the view is different. And you can also customize functionality, as in you can allow certain things to be there, like options menu, or you can remove them and add something of your own. This is how we would talk to the input system. We add an action, and an action, a user action, is something that the user can do, like they can jump, they can left, right, shoot, and so on. And each action has three phases, if you will. Begin, the actual action itself, and then the end. Begin is when the action begins, or the frame in which the action is going to begin. And then until the very end of the action, the on action callback will be called to execute your stuff. And then you provide the trigger, which in this example is qcode.f. And the qcode enumeration comes from JavaFX directly. So if you've used JavaFX, then you already know what these are. And triggers can be anything. It could be keyboard key press, could be a mouse button press, could be something like an Xbox controller or a PlayStation controller, or a touch screen press. So there is a variety of triggers, depending on what platform you're running on and what kind of game you're trying to make. The same API can be represented by this DSL, which is domain-specific language written in Kotlin, but it allows you to call that code from Java or Kotlin. And it's concise, it's much more concise, and it saves you, it gives you sort of the functionality of 90% of use cases, common use cases, which means if you are in those 90%, then you're able to write much shorter code and make it do the same thing. If you are in the 10% and your use case doesn't particularly match the common use case, you then go back to the full API and you'll still be able to implement what you wanted. And that is seen across all of FXGL's code. There is the full API, which is like the original code, and then there's DSL on top of it, which you can use. In terms of built-in dialogues, there's a dialogue service which you can call, and you can construct things like simple messages to display something to the user. You can ask the user something, confirmation dialogue, so yes or no. You can take some kind of input. This is essentially like a text field that you're asking the user to complete. And there is also the whatever you want to have kind of general case dialog box. This is fully customizable. You can put text, images, animations, anything you want. And this kind of covers the general case. If you want a dialog that is not one of the things that we looked at. Isometric views are also possible, so there is no built-in support for that, but using what's already available, you can build something like this. This is just a simple example of a maze built in isometric. There is, when it comes to things like I/O or code that can potentially fail, so networking call potentially, there are I/O tasks that allow you to wrap the code that can fail in a way that it will no longer fail. It will get reduced to one of the existing branches. So it will either succeed or fail, and just allows you to. It's like try and catch, I suppose, but on a more sort of API level rather than language level, and it allows you to gracefully recover from errors within the engine or within your game. And you can also run these I/O tasks asynchronously on a background thread on the JavaFX thread, or you can also run it on the JavaFX thread with blocking dialog. So if you're downloading a file, for example. And here's a sample use case for running I/O tasks in the background. You could have AI being executed in a background thread with the results being then thrown to the UI thread where you actually apply the results. There is built-in localization support. You produce essentially a property bundle that you call it .lang, as in a language. And it's a plain text file which contains keys and values. It's a key-value pair. The key is the unique key for the piece of text that you're translating, and the value is the actual translated text in the localized language. This could be done either at runtime, or you can produce a static file that you can then load. And all of these are going to be JavaFX properties. And what this allows you to do is, instead of setting like a variable, so UI object set.text, you're taking the property of that UI object and binding to a localized version, which means whenever you change the language, the internal value of the UI object is going to be updated to the new language's correct translation. So you don't need to do this manually. Everything is JavaFX properties driven. which is great. We've got networking support. There is essentially the API takes what JDK provides for TCP and UDP connections and then wraps them with a single API. So the only difference between a TCP and a UDP client is literally just the name of the method that you're calling. So instead of new TCP server, you'd say new UDP server. Everything else is the same API, although underneath the backend implementation is actually quite different if you look at raw JDK networking stuff. You can run your servers on a background thread. You can then connect to them. You can connect and handle messages on the background thread, on the JavaFX thread. So there's a variety of things you can do with it. Going now to the particle system. FXGL includes a particle system that can be customized quite heavily. So this is an example of what you can achieve with a particle system. And if we look at this slide, this is essentially the same emitter, but it uses a different configuration, which means the result is going to be different. So obviously we've changed the color, and also we changed how the particles behave. And we can go further and add something like additive blending to it. So we can change the blend mode of each particle, and we're able to get really nice effects. And this is how you might customize your particle system. You just obtain an emitter, and then you set a range of options, properties of that emitter, such as number of emissions, the source image to use for each particle, the emission rate, the size of each particle, and so on. We've also have the scale expire functions, something that gets called every frame of the particle system emission. And somewhat similar, we have animation system, which is, again, customizable. It allows you to change some value, t. I've used the generic here because it really is generic. It can be any value over time. So it doesn't have to be just a float or a double or an integer. It could be color. It could even be string if you wanted to. Like you can animate from one string to another, which will go through the letters in order to get the end value. And you can also interpolate, which is going to change the rate of the animation. You can have two identical animations in terms of they all go from 0 to 1, but the interpolation is going to drive the rate of change. So one animation is going to go to 0.5 value quicker than the other, but they will both reach the value of 1 at the same time, because the interpolation only changes the rate, but it doesn't actually change the overall length. And the animation system extends to 3D in an obvious way. It was initially designed to be 2D only, but since we now support 3D, point 2D just becomes point 3D. So the only difference is just that. So if you want to animate from a two-dimensional point to two-dimensional point, you use point 2D, and in 3D you use the other alternative, and you can produce something like this that you can see on the screen. I suppose I should note that the API stays exactly the same, whether you're doing a 3D animation or a 2D animation. There is built-in profiling sort of support. You can see how quickly your frame is being computed by the JavaFX thread, which is the CPU. And then you can also see how many frames, how many pulses you're getting from JavaFX. And there's also the third tab, which gives you RAM stats. At the end of the run, the profiler will give you some numbers. usually around number of frames that you've produced, and also how much time it took to calculate each frame. We can render large images with FXGL, or I suppose with JavaFX, because remember, everything goes from FXGL to the JavaFX rendering pipeline. FXGL just makes things simpler for JavaFX to process, because if we're not careful, then we can overwhelm the JavaFX pipeline quite quickly. So we have to be mindful about how we are using JavaFX to render things. And if we do that, then we can achieve quite spectacular results. So this is an example of an RPG that has a test map of 500 by 500 grid. And that grid, each of the elements in that grid has 32 pixels tile size. So if you multiply that, you get something like a 16K by 16K image. It's quite big. And that image gets worked on every frame by FXGL to produce something like this. There are various different approaches to do that, but this is just to give you an idea of how fast JavaFX and FXGL together can be. There is built-in serialization support. There is a data structure called bundle, which is like a map. You put some values in it, and as long as they're serializable, we can just automatically serialize that into a save file from which we can then load, and then essentially gives you the ability to save and load your games. There is mobile support using Gluon tools, particularly the client plugin. We're able to compile to mobile. And this is an example of a simple game. This is Breakout. So there are not many entities that you can see on the screen. There are not many game objects. But this example shows how we can get quite a number of things going on mobile as well. And there's zero code change. You take your desktop build, and indeed, this was the desktop build. It had 1080p rendering. It had particle systems set to max, and everything set to max, essentially, because it was a desktop build. And you could just compile that to mobile. It will work with no change to the code whatsoever. It almost runs at 60 FPS. And keep in mind that this is the desktop version. If you render it at 720p, for example, then it will easily run at 60 FPS. There is a controller support, controller meaning something like PlayStation or Xbox controller. So remember the input API that was earlier. What you do is just you plug in another value saying, I want to map this keyboard key to this virtual button. And this virtual button thing is going to map to one of the buttons that you have on your hardware controller. And FXGL is not just for games. Although it is a game engine, first and foremost, it can be used to produce just normal business applications. On the left, you can see a graph visualization algorithm implemented with FXGL. It's quite short, actually. So you can see how beneficial it can be when it comes to things like rendering effects and so on. You can also, sorry?
Yeah, somebody is asking, are there any plans for documentation?
The documentation is currently on GitHub. There is a wiki page which contains documentation, or some of the documentation for FXGL, for the two versions of FXGL that we have. One for Java 8, one for Java 11 and higher. I suppose that answers the question. So yeah, the documentation is ongoing. And the best place to look for that would be the GitHub wiki page. And on the right, we have the FX Hub application, which was like an app store idea where you can get all of the community projects written using JavaFX. and be able to just run it from this application without the needing to kind of know about how to compile, how to get the right command line switches, and so on. We can also produce things like editors. So this is not technically a game. This is an editor in which you can produce dialog nodes, dialog branches. You can combine them. And essentially what you end up with is like a dialog graph where you can put your scripts to run, and then you can export that into JSON and then plug it into your game, where you can, if a game is narrative driven, for example, so you got lots of dialogue, you don't want to be doing that by hand. There's a tool for that, which was built with FXGL. And you can also test your dialogues within this tool as well. So I'll just briefly talk a bit. Yeah, sure.
Share the GitHub link in the chat?
Yep, we can. It's github.com/almasb/FXGL. I don't see the chat button on my screen, so which is why.
If you say that again, I will type it carefully. GitHub.com.
Or just Google FXGL. The first thing that comes up should be the GitHub link.
FXGL. Very good.
Yep, that'll be easier. So I'll just very briefly talk about the architectural model of game objects within FXGL, and that is essentially the entity component model. It's not the full entity component system model. It's a modified version where you have just entities and just components. Everything is an entity. The game objects that you see on the screen, the particle effects, the grid lines that you currently are seeing in the screenshot, the enemies flying around, the bullets, all these things are entities. Or you can think of them as Java objects that have no fields or no methods. They're just objects with no information. Components hold both data and behavior for each such entity. These provide the fields and methods, so you can essentially you can add new fields and new methods to your objects at runtime. So that's quite powerful. And because they are separated in that way, each component only worries about its own data and behavior. For example, like position component, which will only worry about position. You have met the single responsibility principle, essentially. So here, the example is position component, which has only two things, X and Y variables, and the behavior, which is move. In terms of built-in physics, there are two engines. One is the lightweight, which is the FXGL's implementation. The other is heavyweight for simulations with JBox 2D for that, or the modified version of JBox 2D. And depending on what you want to do, you'll be switching between the engines. So one, and actually you don't need to do any manual switching. Everything is done for you by FXGL. So if you want to check for collisions, and they're reasonably simple shapes like rectangles, squares, circles, then the lightweight physics will take care of that for you. It's either bounding box, axis aligned bounding box collision detection. If you're using two rectangular shapes that are axis aligned, if they're not axis aligned, that means they are rotated in some way. Then we use the separating axis theorem to quickly tell you if two entities are colliding. You can enter the developer mode, which is currently in development. But in that mode, you can see the bounding shapes for your entities. So the red rectangles are the bounding boxes. And each entity can have multiple hitboxes, which together make the bounding box. With the heavyweight, you have this physics component that you can attach. Then you're basically turning your manually controllable entity into something that is controlled by the physics world, by the simulation. So you can no longer do things like set X and Y values in 2D space. It will be set by the physics engine that runs the simulation. And that allows us to do things like rigid body dynamics, where you, for example, take the ball that you can see on the screen and then kind of throw it at this tower-looking thing. Well, it was before it got destroyed by this ball. And you can make something like a snooker game with rigid body dynamics. There is a plethora of post-render, baked post-render effects. So although they're post-render effects, they're not actually rendered in post, they're pre-rendered. And this allows you to get to zero rendering overhead. You can just get these effects basically for free. And well, the cost of that, I suppose, is they're not dynamic. So if you're looking for something static that you can move afterwards, but the texture do not change, that's fine. But if you need something like where the animation is going and then you need to blend the animation into something else, you can still use the JavaFX blending. There is also AI support. This is providing an A-star implementation for the pathfinding. You have 2 points in your 2D space, for example. You have some obstacles in between, and then you're saying, well, I want you to go from point A to point B without hitting the obstacles. And the A-star pathfinding algorithm will give you the shortest path. There is support for external tool integration. So we can, on the right-hand side, you can see the tiled map editor software, which is quite popular among 2D game developers to produce these levels or maps. And you can just export that as a TMX file, which is the native file that this editor will produce. And then you can load that into FXGL, which is what you can see on the left. And the code for that would be, you specify how each object needs to be created. And then the only line of code you need is set level from map. And that will take care of everything for you. And this is an example level produced using this approach, and also combines the static entities, which are part of the level, and also dynamic entities, which is something that you spawn at runtime. This is the tentative design for the editor, because currently FXGL's capabilities, you can only utilize through code. So you can treat it as an external library. It's not an application that you can run. With this, the plan is to develop an application in which you can, without code, access FXGL's features for game development. So it'll just become like a normal game engine. Right, which brings us to the simple practical example. I'm going to very briefly go through the lines of code that we can see. We already looked at init settings. We've looked at public static void main. So the only new thing here is init game override, in which we ask FXGL to give us an entity builder. We supply the view, which is going to be a rectangle, or I suppose a square. And then we're saying build this entity and attach it to the game world. A lot of the complex APIs are fluent API, meaning you built one on top of the other. And the only thing we've done here was we created a private field called player of type entity. And then we assigned the result of build and attach, which we did on the previous slide. So we can get a reference to the player game object. Entity is a game object. In initialize input, we've added on key down handler, We're saying when W is pressed, we're going to run this bit of code, which is on the right-hand side, the Lambda code. And that is going to translate the player's Y value by -5. Essentially, it's going to move up, because in FXGL and in JavaFX, positive Y goes down, negative Y goes up. And similar things for the other axes, or the same axis but different directions. And if we wanted to add custom functionality to our entity, because remember, an entity is just an empty object. It doesn't have any fields, methods, or anything, any logic. In order to add logic, we need to add a component. And this component is called spin component that we just created. And in its onUpdate method, we're saying we're going to rotate our entity by 90 degrees every second. And you multiply by time per frame to avoid problems if your game is lagging, for example. And once we attach that by using with new spin component, our entity is going to then rotate by 90 degrees every second from then on. Right, so we are at the end of our talk. To summarize what we've looked at, FXGL seamlessly builds on top of JavaFX. So if you can build something with JavaFX, you can definitely build that same thing with FXGL, and it will be quicker. And FXGL makes the app or game development easier and more robust by providing access to real-world tools and techniques. So the entity component model, for example, the same or similar model is used in Unreal Engine, in Unity. The A* pathfinding is used in many engines and many games. So all the tools and techniques come from game development research, conferences, or existing engines. So if you're interested and want to be involved, any of these things is a great way to contribute. You can either crash test features for bugs or write a unit test for one of the features. So this is code contribution. You can create an issue, or you can suggest a new feature backed up by use case. You can provide or suggest an implementation of an existing issue. You can sponsor the project, $1 a month on GitHub. You can proofread public documentation for errors, ambiguities, typos, or you can write public documentation into the wiki section. Or you can start a project repository to show interest, again, on GitHub. And there's also going to be an event called Hack Commit Push on May 29th. And that's going to have FXGL as one of the projects that you can select. So you can contribute to that project. There will be project coordinators. I'll be there as well to help new contributors with the process and everything related to FXGL. On that note, thank you very much for listening to me talk about FXGL. These are links that you may wish to explore if you're interested in FXGL. And I'm happy to answer any remaining questions.
Well, thank you, Almas. We have a number of questions, and anyone who'd like to post more questions in the chat, please feel free to do so. I'll keep my eye on the chat while I ask the questions that we've already accumulated. The first one is, what type of apps are not applicable for FXGL? What are FXGL's limitations, if any?
Well, I would say anything that is of AAA title. So if you want to produce a really complex game that looks like something that was produced by a well-known games company, then that's not something that you can build with FXGL. You will need Unreal Engine, Unity, or something along that sort of level. In terms of business applications, I currently don't see any limitations, because anything you can build with JavaFX, you can build with FXGL. It's a direct superset. In terms of games, anything that is 2D should be doable easily, because that was the original aim of FXGL. In terms of 3D, it's still in development. So it will take some time before the support is up to speed.
Can we use standard JavaFX components along with FXGL?
Yeah.
Are there any Z ordering issues to be aware of? Image transformation, etc.?
You tell what things should be on top, what things should be below. There's a whole Z ordering. You just say, I want this to be at Z level 10, and then something at Z level 20. The higher thing wins.
Can FXGL generate sound as opposed to
Yes.
just playing MP3 and wave clips?
Well, actually, generating sound, could you elaborate on that?
Well, can you program it so that it creates a sound as opposed to scooping up a sound that's already prepared from a file? And
Right. By default, there is no built-in functionality for that, but I can remember Java has MIDI API they can call to produce sound effects from various instruments. So from that perspective, yeah, because you can use any Java API available, including stuff that's built into the JDK. So I would say, yeah, that's possible.
so are events in FXGL really JavaFX events, like as in JavaFX.event.event?
Yeah, yeah.
So there are no race conditions with the two event systems?
No.
Okay.
Everything related to events is pure JavaFX stuff. They are rerouted to various things, but the event that you're going to be firing is going to be JavaFX event.event.
Is there an advantage, or what's the advantage of FXGL networking over standard Java networking?
It's the same Java networking. The only advantage is in the API, as in you don't need to talk to anything related to JDK layer. So it's abstracted. And you can switch between TCP and UDP quickly. And also the game stuff, like you can send data from one instance of your game to another much easier than if you were doing it with JDK, simply because there's API for that. But from functionality perspective, there is no difference because it's the same backend that we're using.
Thank you. With that, I'll turn it back to Rodrigo to finish up our grand performance today.
All right, thank you, Barry. One last time, to participate in the JetBrains raffle, write a tweet with the topic or speaker that you would like to see here at the jug. Here's and please tag the NYJavaSIG. Okay, we're gonna raffle one JetBrains license that you can use to have access to any IDE from JetBrains for a year. Our next meet will be on May 13th, right? We're gonna have Max Anderson talking about JBang, so you can run Java as a script from anywhere. Should be a very interesting topic. Almas, thank you very much. I love the presentation. I love to see what FXGL can do. I had no idea that you had so many options and it could be so much powerful. Thank you very much. It was really nice having you with us.
Thanks for having me.
Thank you for everyone for watching.